Alright guys, Mr. Jared here, and today we're going to be doing another math video, and this time we're going to be talking about adding and subtracting mixed numbers. Okay, first we're going to be just tackling the addition side of things. So the best thing to do, and we already know that whenever we're adding fractions with common denominators, we just add the numerators and keep the same denominator. Well, when adding mixed numbers, it's essentially the same thing. It works just like you want it to. So let's go ahead and get right into an example here. So say we have 2 and 2/8 plus 3 and 3/8. Okay, now notice both of our denominators are the same, okay? So that makes our life quite a bit easier. Now to do this, first we're going to add up our whole numbers. In this case, obviously 2 plus 3 is of course 5. Next, we're going to be adding our fractions. Okay, so now 2/8 plus 3/8. Again, we have the common denominator of 8. And then 2 plus 3 is 5. Now, again, we're not so much concerned about simplest form as long as our answer is in fact in mixed number status. So notice with mixed numbers, you have a whole number and a proper fraction. Now I say proper because this fraction here, the numerator must be smaller than the denominator. You cannot have an improper fraction here, otherwise it is not a true mixed number, okay? Now, we're going to do one such problem in just a few moments. But first, I want to show how we can model this addition, okay? So first, of course, we need to draw our 2 and 2/8. So, here. Now, this will be my first hole. This will be my second. So now all that's left, we've got that taken care of, our 2. Now all that's left is our 2/8. So, let's go ahead and draw that out. We can do that by splitting it down that way, that way, that way. And now we have 4, and then just a horizontal line. Now, here we have 2, 1, 2. Okay, so there is our visual representation of 2 and 2/8. Now, the easiest way to do it, in my opinion now, is to just go ahead and draw the other ones right next to it. So here's another hole. And if you want to maybe do something a little bit extra, like scribble it horizontally or something like that, to signify that we are doing the 3 and 3/8, that's perfectly all right. We're going to do that over here as well. Okay. And then finally, this will be block number 3. Now, we already have some blank 8s right here. So the easiest way to do it, since we are in fact combining them, is to just go ahead and use these up. And we need 3/8, so 1, 2, 3. Now it's just a matter of counting what you have. If you notice, we have 1, 2, 3, 4, 5 holes. That's we have our 5. And then we have 1, 2, 3, 4, 5/8, which is also our fraction. Alright, this is how you would go about modeling an addition problem for mixed fractions. Mixed numbers, pardon. So, now that we have accomplished this, let's go ahead and talk about that other type of addition problem that may arise when dealing with mixed numbers. Okay, so let's go ahead and scoot it over here. Now, say we have the following problem. 1 2/4 plus 3 3/4. Okay, now to solve this one, we're going to do exactly the same way that we did last time to begin with, of course. So 1 plus 3 is going to be 4. Next we add our fractions. 2/4 plus 3/4 is going to give us, well, we have the common denominator, which is 4. And 2 plus 3 is 5. Now here's where our problem comes into play. I just said moments ago that in order for our answer to be truly complete and in mixed number form, we must have a whole number, which we do, it is a 4, and b, a proper fraction. And our fraction is 5/4, which the numerator is larger than the denominator, so therefore that makes it a improper fraction. So we're not entirely finished yet. Now, but we can solve this problem by simply turning our improper fraction, the 5/4, into a mixed number. Now, remember, every improper fraction can be turned into a mixed number. Now, so we're going to come down right below it and just turn it into a mixed number. We do that, of course, through simple division. I'm going to drop my 5 down here. Alright, how many times will 4 go into 5? Well, we can get 4 times 1, which would equal 4. And simply subtract that. 5 minus 4 is 1. Now, remember with division, we're only done until our bottom number here is smaller than our divisor. So, is 1 smaller than 4? Absolutely. So this 1 becomes our remainder, and our quotient is, of course, 1. 1 or 1. Next is to simply turn our answer to our division problem into an actual mixed number. And we do this by taking our quotient, this 1 here, that becomes our whole number. Then our remainder becomes our numerator. And then, much like with most of these division problems, we simply keep our denominator, which in this case is the 4. The 4 goes down below, and right there you have it. It is now a mixed number. We have our whole number, and our fraction is now proper. Now, here's the last step to finishing our problem. We do not need to forget that we still have this whole number of 4 up here. Now, it's a very simple solution to our issue. All we do now is simply add our 4. So, 1 plus 4 is 5, and then we don't have a fraction here, so the fraction just carries over. So 1 plus 1/4 plus nothing is still 1/4. Now, this problem can be modeled exactly the same way, and as a matter of fact, I'm going to do that right now. Now I'm going to go ahead and write our problem again right up here at the top, and that was 1 2/4 plus 3 3/4. Alright, now let's remind ourselves that our answer that we got was in fact 4 5/4, which we later determined was 5 1/4. Okay. Now, if we are asked to model this, we're going to do it the exact same way as before and simply model our mixed numbers one at a time. So the first one is 1 2/4. So we're going to draw one box for the 1 and then I'm going to come over here and do my fraction. Again, for all intents and purposes, our squares are the same size. So there's my fourths, and here is my 2. Okay, now for our 3 3/4. So 1, 2, 3. So there's our 3 holes. Now for our 3/4. Now, just like last time, let's go ahead and use up what we have right here. So there's 1, 2. We've run out of room. Well, we still need to do one more fourth because we only got 2 here. So we will have to go ahead and draw another square into our fourths and then get that last one in. Now, lo and behold, notice how now we have 1, 2, 3, 4, and then we have 1/4, 2/4, 3/4, 4/4, and 5/4, just like we had right here. But here's the visual part. Notice how whenever we were doing our 5/4, we ran out of blocks. We had to go into another one. Whenever we ran out, that created another hole. So now we essentially have 1, 2, 3, 4, 5 for our whole number, and then just 1/4 for our proper fraction. Alright, that's the reason why we have to turn our improper fraction into a proper fraction. That way we have the correct whole number. Alright. Well, that is pretty much it for the addition. Okay, so next we're going to be talking about subtraction. Now, subtraction, go to a new page here. Subtraction is done exactly how you would want it to be. Now, I said that last time with the addition, but I mean, it really is. Okay, so let's just jump right into an example. Now, this is going to be a relatively common one, and that will be 3 3/8. I say common because there's no funny business, to quote a student, involved. 2 2/8. Okay, so now we have 3 3/8 minus 2 2/8. Now, just like with the addition, we're going to start with our whole numbers. So first off is 3 minus 2, which is 1. And then 3/8 minus 1/8, or 2/8. Now remember, just like with addition, if our denominators are the same, which they are, it just carries over. Now we have 3 minus 2, which is 1. And it is as easy as that. So 3 minus 2 gives us a whole number of 1, and 3/8 minus 2/8 gives us a proper fraction of 1 1/8. Now our answer has a whole number and a proper fraction, which is 1/8. Our numerator is less than our denominator. So for all intents and purposes, we are finished with this problem. Now, one way you could model this, and it's one that I really enjoy, is simply model the first one. When we draw in our boxes again, there's 1, 2, 3, and then we're going to draw our fraction, which is going to be 3/8. So we need to separate our rectangle into our 8 parts, and then shade in the 3. Okay, so there's our 3 3/8. Now we need to take away 2 2/8. Now, the easiest way I know how to do this is to simply just put a giant X over whatever we take out. So first, let's take away our 2 holes. So we'll put a giant X here, and there's 1, and then 2. All right. Next up is our 2/8. This one you're going to have to make some smaller X's, but it'll get the point across. There's 1, and there's 2. Now, all that's left now is to simply count what you don't have a mark through. 1 whole, which matches our answer, and 1/8, which goes with our proper fraction. All right? Now, that is the easiest form of subtracting mixed numbers. So, now let's go get into one that requires just a little bit more thought. Not too terrible, not too terrible. Okay, so, for instance, if we have the following problem, 3 2/4 minus 1 3/4. Now, to begin with, we have no issues here. I mean, obviously, if we started with our whole numbers, we would get 3 minus 1, which would be 2. However, if we go on and try to do our fraction, we have 2/4 minus 3/4, and, well, 2 minus 3, that doesn't really work out. So, we have 2 options here. Now, the first would be to simply change both of these into improper fractions. Okay? And then just subtract across. If you can convert mixed numbers to improper fractions quickly, then that may be the method that you want to go with. And I will show that method. But first, I want to show you how we can borrow. Okay? So just like with regular subtraction, if, say we have 10 minus 3, okay, or better yet, 20 minus 3. You cannot take 0 minus 3, so you have to borrow from the 2 to make it a 10. And then 10 minus 3 is, of course, 7, and carry the 1, 17. But with fractions, it's the same type of idea, okay? So we're going to essentially change our 3 2/4 into a whole number and a smaller improper fraction. Now, you do this by realizing one thing, and that 1 whole is 4/4. Okay? So, for instance, in this situation, we're going to want to borrow 1 whole from the 3 and make that into a 2. Okay? But we've taken 1 whole away, and remember, 1 whole is 4/4. So we're going to have to take our 4/4, right? So far, I've still got the 3. This is the same thing as 3. And then tack on our 2/4 from before. So far, I have not changed our number at all. Because 2 plus 1 is 3, and plus 2/4 is 3 2/4. It's very important that you realize that 4/4 is no different than 1 whole. If I have 4 pieces of a puzzle, and that's all that it requires, then that is a whole puzzle, the entire thing. If I have 4 pieces of pizza, and that's what it's been, and I don't eat any of it, well, guess what? I've still got 4 pieces of pizza, and that's the whole pizza. Okay? That is the key here, okay? So now you simply add up your fractions. That comes out to be 2 6/4. Now, I know what you're probably thinking. I just got through saying that a proper mixed number is just a whole number with a proper fraction, and that if it's not a proper fraction or an improper fraction, then if it is an improper fraction, then it's not a full mixed number. Well, I understand that. However, for our purposes, this is the way that you have to go. Because now that we drop our minus 1 3/4, you're going to soon realize what I'm talking about. Now, let's go ahead and try to conduct our regular subtraction. So we have 2 minus 1, which is 1. Now we have 6/4 minus 3/4. Well, Our 4 carries across because we have a common denominator. Next is 6 minus 3. 6 minus 3, excuse me. And that, of course, is going to give you 3. Now, our answer, if you notice, is 1 3/4. Also, this number is proper mixed number, meaning we have a whole number and a proper fraction. Our numerator is less than our denominator. So, I mean, this is absolutely correct. So, what I want you to take from this is that although you are changing a mixed number, a proper mixed number, to an improper mixed number, meaning we have a whole number and an improper fraction, your answer will come out to be a proper mixed number because of the borrowing. Okay? Now, we can also show this through modeling. Okay? I'm going to do that right over here. Let's be reminded of our problem again. Our problem was 3 2/4 minus 1 3/4. Okay? Now, first we're going to draw our first mixed number because it's obviously the largest. 3 is bigger than 1 all day long. Okay? So, we draw our boxes. There's 1, 2, and 3. All right. Next is going to be our 2/4. 1 and 2. Okay. So there is our 3 2/4. Now let's go ahead and try taking away our other mixed number. So first we've got, there's 1 gone, 1 whole. Now, all that's left is our fraction. So here's 1/4, 2/4. Oh, now here's the problem. Notice how now our fraction is gone. This is exactly the problem that we had in the last situation. So, this is where the visual representation of borrowing comes from. We have to go to one of our wholes, either one, and turn it into fourths. Just like we did the last time. Whenever we turned in one whole into 4/4, that's exactly what I'm doing over here. Okay? I'm going to turn this one right here. See if I can make it dark enough for everybody to visually see this. Okay? Now I hope you can see that that is 1 piece, 2 pieces, 3 pieces, 4 pieces. Okay? Make the outline to it a little bit darker. Okay. Now we already taken 2/4. We still have 1 more fourth to go. So we take away this one. Now, just like last time, folks, just like last time. Whoop. My camera's a little bit wobbly. We count what we have left. Okay? So we have 1 whole. 1. And then we have no fourths over here. So we have 1, 2, 3 fourths. Which, if you look back, that is exactly what we got using the other method. Okay? So now here are the two of my favorite methods to subtract mixed numbers. Now, if you recall, I did mention another way of subtracting mixed numbers is by simply turning them into improper fractions. Okay, now remember, you can manipulate mixed numbers by first converting them into improper fractions, then taking your answer and changing it back into a mixed number. Now, if you can, like I said before, if you can change mixed numbers to improper fractions quickly, especially if you can do it in your head, this may be the route you want to go. And let me show you why. Let me just show you why. We're going to be using our same problem as before where we had to borrow. Okay, I'll go to a new page. We will be using the exact same problem. Okay, no indentation from that last problem. Okay, so here's 3 2/4. Okay, minus 1 3/4. I'm trying to figure out what that is. Now, if you recall last time, we did have to borrow. Okay, but if we change them into improper fractions, you're going to see why that is going to be unnecessary this time. So again, to change a mixed number to an improper fraction, we multiply the denominator by the whole number, which 4 times 3 is going to be 12, and then add the numerator. So 4 times 3 again is 12, plus 2 is 14. Remember, it goes clockwise, okay? Starting from the denominator, ending at the numerator, okay? 14 is going to be our new numerator, and our denominator stays the same. Next, we have our minus symbol, same process. For our next mixed number, 4 times 1 is 4, plus 3 is 7. Again, going that clockwise motion, starting at the denominator, ending at the numerator. And my denominator is going to be the same, which is 4. So now, well, it's just easy subtraction straight across the board. 14 minus 7 is 7, and then of course your denominator stays the same. Now comes the only extra bit, and that is changing our improper fraction back into a mixed number. So we do that through division, just like last time. Let's see, 7/4. Write my 7 down in here. 4 times what gives us something close to 7. In this case, it's just going to be 4 times 1, which equals 4. Going to subtract that 4 to get us 3. Again, check to see which is larger, our divisor or our bottom number. In this case, it is our bottom number, so we know that 3 is our remainder. Now, and of course, our quotient is 1. This means that our mixed number is going to be our quotient, which is our whole number. So it is 1. And then my remainder is going to be my numerator, which my remainder was 3. And then we keep the denominator, or our divisor. Our denominator and divisor, same thing, which is 4. So we got 1 3/4 through this method, and we also got it using those methods. Our answer stays the same. So, and this process works the exact same way with improper fractions. If you have two mixed numbers, no matter what they are, and simply change them to improper fractions, add the numerators, and then turn it back into a mixed number. It all works the same. It's whatever's least complicated for you is the method that you need to do. In my personal opinion, I do like changing them into improper fractions just because, well, I've done quite a bit of it, and I can change mixed numbers to improper fractions in my head fairly quickly. And then do the subtraction and then change it back. So it is less steps to remember that way. And if that is the method that you choose to use, more power to you. Alright guys, that is all for adding and subtracting mixed numbers. Remember, if you have any questions, please feel free to email me in the email in the description below. And have a great evening. Bye-bye.